And welcome back for our third speaker today on stage one. We have with us ELLE O'Brien. She's a data scientist at Iterative, which is a startup which is specialized on tool and softwares for machine learning. But she's also a teacher, actually a lecturer at the University of Michigan for the School of Information. So thank you for being here, ELLE. Can you hear me? Are you with us?
Yeah, can you hear me?
Hi, yes, nice to meet you.
Thank you. I'll just jump into the talk.
Yes.
Good. Okay, great. All right. Thanks for the intro. So today I'm going to be talking about automating machine learning with continuous integration. So a little bit about myself first. So for most of the last decade, I've worked in academic research in various areas of neuroscience. And one constant in my work is that I've always done a lot of mathematical modeling, and I love getting to use very big computers. So when I got my PhD last November from the University of Washington, I was interested in how scientists and academia and industry use computers and how we're going to build tools that enable high quality science as our methods and data sets and problems all seem to be getting more complex. So I joined Iterative as a data scientist last year, and our flagship project is open source software called Data Version Control, or DVC. And DVC is a tool that adapts version control systems that software engineers are familiar with for machine learning projects. And as an organization, we live at the intersection of data science and DevOps. So I'm going to share some of what we've been working on lately. Oh, and one more thing to note is that as of this past Monday, I'm officially full-time at the University of Michigan School of Information. So I'm still doing advocacy work for DVC, but my full-time appointment is now at the University of Michigan. So let's start with a figure from a really, I think it's a pretty useful case study about teams all across Microsoft. So the authors reported that teams, whether they worked on speech or search or ads, as long as there was machine learning involved in some component of their software, they tended to follow a similar workflow with some steps that occur over and over across teams, regardless of their domain. And we see that there's, a workflow, but there's also some cycling back between things like model training and feature engineering, or evaluate a model and start all over again. And of course, there are a whole bunch of folks with different skill sets working on this. We have data engineers whose job is to collect, clean, and label data. We have data scientists who are engineering features and then training and evaluating models. And software engineers are deploying and monitoring applications built around those models. And this is, for the record, a business run entirely by baby animals. I just wanted that to exist. Anyway, this is all fine if the project proceeds linearly, passing off like a relay race from your data engineer to data scientist to software engineer. But of course, that pretty much never happens. We know that excellent machine learning models rely on feedback, which means that software engineers and data scientists might have to pass several modeling experiments back and forth. Data scientists need to be able to anticipate the system constraints of software engineers who will deploy their models. And everybody needs to know where exactly the data came from. So there's a lot of back and forth, and that can get pretty confusing for any organization. The complexity adds up very quickly. But even though machine learning is a relatively new part of software engineering workflows, software engineering itself isn't a new discipline. And we think we can learn a lot from the field's evolution. And specifically, DevOps has had success bringing together developers and operations specialists. So there is reason to hope that, looking at the successes of DevOps, that maybe we could apply some of those lessons to helping engineers and data scientists work together also. So one of the big ideas from DevOps, which has really changed the way that multidisciplinary teams run, is called continuous integration and delivery. And we abbreviate that CI/CD. So CI/CD is a practice that establishes collaboration rules between developers and operations specialists. So we'll take a look at what this means in particular, because it's not just a philosophy. Well, it's both. It's a practice and a philosophy is how a lot of people describe it. So here's some of the practice. When you make a change in your source code, a build happens automatically, and then some tests get run on that build. And if the build passes the tests, the modified source code becomes a candidate to be merged into the main branch of the project and possibly deployed. And if not, then you go back and you keep iterating. And the idea is that every action, like a git commit and then push to your repository, triggers feedback, and every round of feedback produces a release candidate. So you're testing constantly and you're always ready to deploy, are some of the ideas here. So let's take a look at what's different when you introduce machine learning to this workflow. So first of all, it's not enough just to monitor your code for changes. So in machine learning, your data matters as much or more, and usually more than your code. Your data is pretty influential. So if your data set changes, then you pretty much want to retest everything. And so you have to monitor your changes in your data, not just your code. In addition, we're not just building anymore, we're training. And training can be a pretty resource intensive kind of process. Sometimes you'll need high memory instances. You might need a GPU. So it's not trivial sometimes to do training, at the scale of data that a lot of us work with. And finally, running tests. So here that metaphor starts to get a little stressed because if we do test models, but they're not these like binary pass fails anymore. You'll get back some metrics, and you might know, okay, overall, my new model has improved on accuracy, but maybe at the expense of precision. And so you'll often want a domain expert like your data scientist in there to say, is this an acceptable change? Because of what counts as a regression might not be so clear. So why don't we have this yet? A few reasons. One is that version control doesn't always play nice with big data. If you've got a large data set, you're often not keeping that in your Git repository. So how do you track that the data changed in order to be a trigger? Training models isn't like building software. So, like I've said, we've just got some different hardware requirements potentially. And evaluating metrics is more complicated. So you're not just going to want to slot in a bunch of binary tests. Some binary tests are good, but you also want more detailed reporting. So what's needed, we think, the hypothesis. We think that we can build tools that extend CI/CD practices from software engineering to machine learning, and we are people that make tools, so this is the angle that we're going in on. So if we were to kind of construct a wish list of some of the features we might want for machine learning and CI/CD to work together, it might look a bit like this. We want to be able to version data like code. We want our CI system to be able to allocate whatever hardware is needed to train models. And we want metrics about model performance to be reported in a human readable format so that it's pretty efficient for data scientists and other team members to review them, kind of like we can review code on a pull request. So here's how we are approaching it. The work I'm going to show you today in this project is a collaboration with Dmitry Petrov, David Ortega, and myself. DVC is a co-founder of the company, DVC creator. David Ortega is a developer, and I'm a data scientist. So, having told you a little bit about what we want, now I'm going to tell you a little bit about kind of our perspective in going after that, accomplishing that wish list. So our team is really into the Git ecosystem. We like Git tools because they're so well established in the software development community, and we think they can be adapted to work better for data science projects. And in fact, our flagship project, DVC, is just adapting Git for large data sets. It's not a replacement for Git. It is Git, it works with Git. So, we're pretty heavily embedded in this ecosystem already. And we think there's a lot of really impressive developments coming out every day here. And so two services in particular that have really caught our attention and kind of inspired us are GitHub Actions and GitLab CI. So these are systems that are designed for Git-centric continuous integration. Both of them will offer, some computers that are totally managed by them. You can also put in your own instances, but you could use, GitHub Actions, and you can create a workflow that will run on, computers managed by GitHub. So it's quite nice, for a lot of lightweight CI/CD setups. Now, there's a tremendous overlap in what you can do with GitHub Actions and GitLab CI. So for the most part in this talk, I'm going to talk about GitHub Actions just because of it's, totally free to get started. And they, give you a certain number of compute hours per, for free public projects. But please know that everything I'm saying you can do in both of these systems. There's really very little difference and they're both phenomenal. Okay, so now our project that's been kind of inspired by those two services, and I'll jump into how they fit together soon. So our project is called Continuous Machine Learning. This is our fancy logo. And we are an open source project, and we're trying to adapt systems like GitHub Actions and GitLab CI to work better with machine learning projects where you might want some continuous integration. So 2 ways to follow the project. We have a cml.dev website, and we also have our project Git repository. And that's kind of the hub for issues, feature requests. So just 2 places to be aware of on the internet. Okay, so to jump back to here and explain, okay, so where does CML and GitHub Actions fit in this workflow? So we can think of GitHub Actions or GitLab CI helping us with this part of the process, automating model training and testing. So GitHub Actions runs a workflow that's defined by you every time a triggering event happens. Like, for example, if GitHub detects that you've just pushed a change to the project repository, it can run a workflow and then report back the results of it. And by default, the workflow will be run on machines that are totally managed by GitHub, but you can use your own machines too, and we'll revisit that. So I'm going to take us through, to introduce the tool, the priorities that we laid out one by one, and show you how our tools kit is, handling them. So first, let's talk about providing feedback in the form of metric reports. So let's take a look at a sample GitHub Actions workflow. So say that we have a project on GitHub and we're using GitHub Actions to automate training and evaluating a model. We're going to create this YAML file and a special file path. So this is kind of the secret for any GitHub action, is that you'll always put a file in this .github/workflows. You can call it whatever you want. It just has to be a YAML. So a couple things go in the formula. We are going to set a trigger. So we're going to say, okay, on push, anytime a push is detected to this repository. We're going to pull a Docker container. So this is our Docker container. It contains the CML functions, also some helper things for Python 3, but there's really nothing special about our Docker container. You can do this without our Docker container too, as long as you just install the right dependencies. And then we're going to run a Python training script. So Python, train.py is a script that's in our repository. So as requirements.txt, we're just going to do install requirements on the runner or train. And then we're going to do some bash scripting with these helper functions. So CML publish and CML send comment, those are functions that we've written. And what they're going to do is help us take outputs from our Python training job and report them to GitHub. So what this looks like is that when you make a pull request, your job will run, and then you get a report that looks something like this in this example. So this is reporting the accuracy of the model and then a confusion matrix on some held out data. And so the idea is that, if you have this in your pull request, then maybe it will be easier for your team to discuss and make an informed decision about what you're merging. So to take a closer look here, we have a training script that outputs a text file of metrics and a confusion matrix. Then we do some bash scripting with our helper functions to add the reported model accuracy and our confusion matrix to this markdown report. And then it's just like a made up markdown report. It can be called anything. And then we take that markdown report and we send it with CML send comment to GitHub, and it ends up in your pull request. Another example, so DVC has some features where you can compare metrics of models across different Git commits or Git branches. And so if you use this with CML, then that gives you the ability to write out tables and graphs that are going to compare what's on the head of the current branch to what's on the main branch of the project. So you can kind of see a diff for model metrics if you are to combine some DVC functions with the CML report feature. But you don't have to do this. It's just, DVC and CML are separate, but this is something that it lets you do. We also made a helper function so that you can get a link to a tensorboard.dev page. So even if your model is training on, say, GitHub's machines, you can watch it train in real time on your TensorBoard link. And reports are made to be super flexible. So we just look for, a markdown document, and you can put in anything that can go in GitHub Markdown can go in the report. So you could make your plot using whatever visualization library you prefer. So it could be Seaborn or ggplot or Vega or pretty much whatever. And likewise, any way of writing a table too. Even though I'm showing you Python examples, there is nothing special about Python. This is all pretty high level. And so like Git, it's language agnostic. So a few ways to use these kind of reports. You could report about model training on remote machines. So you could find out, how long did your model training take. You could look at the loss function. You get transparent, reproducible, and detailed test results. So you can pretty much put as many test results as you'd like in the report, and review data and models like code. And I have a YouTube channel where we're building up use cases. So like all of these kind of potential use cases, I have a YouTube channel where, we try to make videos about them and show how they could look. So definitely consider checking out our YouTube channel. Okay, a second priority. We wanted to be able to version data like code. And this was kind of accomplished by DVC. DVC sort of needed to be there in order to build CML. And so DVC, to talk a little bit more about it, as I kind of alluded to, although people often think DVC is a Git replacement, it's not. DVC is working with Git. You need both. So DVC extends Git versioning to data sets and models. So it's got this syntax where you'll like add a big data file, DVC add, and then you can push. And the idea is that kind of like how you have a Git remote for keeping your code, you also have a data remote. And that data remote can be any kind of cloud storage. So we support pretty much all major, cloud storage vendors. And so when you do a push, you're transferring that CSV from your local machine to cloud storage. And then DVC treats data as code so it can be Git versioned. What that means is that on your local machine, after pushing that CSV file, into the cloud, you're going to get a lightweight metadata file. So it's going to be called like data.dvc. Data.dvc or data.csv.dvc. It's going to end with that. And it's going to look something like this little file here. And it's going to contain a hash that indexes the version of your data set as well as its location in cloud storage. So that means that you can version data, even though the data doesn't ever have to live in your Git repository. The data lives in the cloud and you get these lightweight files that are really trivial to version with Git. And DVC then helps you put them together so you can pull your data and push it, at any time. So we have worked out a way in CML to give your GitHub Actions access to your DVC remote, which means that you can do something like this on your runner, the machine that's running the workflow. You could do DVC pull data, and that will take data that is stored in your S3 bucket or your GCP bucket. It will pull it to the runner and then reproduce some workflow. DVC repro is basically like a make file, but it's specialized for DVC. And then we can do at the end, maybe if we produced a model, we can push that model to the cloud. So you don't have to deal with trying to store models or data sets in your Git repository, even though we can use these GitHub-centric tools. So here we go. Pull data from the cloud, push data back to the cloud. So some consequences for continuous integration is that changes in your data set can trigger GitHub Actions, even though the data set itself is not Git tracked. You have this metadata file that's Git tracked, but the data itself never touches your Git repository. And GitHub Actions can now push and pull big artifacts to cloud storage with this kind of nice high-level syntax. You don't have to like hard code the address to your bucket or anything. And data and model versions will be linked to every model training run. And so one potential benefit is less servers because you don't have to use a file server. You're just using a serverless solution like S3. All right, now finally, the third priority. We wanted our CI system to be able to allocate cloud resources to train models. So this is a really cool feature. We had originally done this with Docker Machine, but we've just released an upgrade. It's in the pre-release right now, where we're using Terraform together with our CI system. And what this means is that you can actually push to your repository, and that will initiate training a model in the cloud. And so what that means, so for example, this is a neural style transfer example. So we created a GitHub Actions workflow that will provision a brand new EC2 instance with the GPU. And then we set this machine as the place to run the workflow, and we run the training script there. And when it's done, it shuts off, and we're going to return back this report to my GitHub, the pull request. So how it works is we have this really nice, pretty high level function called CML runner. And this is wrapping a Terraform provider. And what it means is that you can declare a vendor. So AWS and Azure are supported right now. GCP is coming. You can pick a region, an instance type, and you can pick something. You could pick a T2 micro, practically free. You could get a GPU, basically whatever you have permissions for with your AWS credentials, you can have them. You can have spot instances, which is really good way to keep your prices down. And then you can just launch this and your workflow can run on this machine. And I think my favorite part of this is that you don't have to remember to turn off your GPU because you're not interacting with it through a dashboard or even a terminal. You don't have to interactively engage with your cloud resources at all. You modify your code from, whatever machine. It can be from your laptop. You push it to GitHub or GitLab, and then that will totally handle turning on the workflow, installing all dependencies, pulling in the right environment. And then when it's done running the workflow, it turns off. So you basically never have to interactively engage with the cloud resources that are going to be running your job. So kind of to put a lot of this together now, I'm going to zoom out and show a sample use case. So a use case that I worked on with Jeremy Jordan, who is a software engineer and data scientist. We wanted to do some automated model testing in the area of natural language processing. So we were inspired by this paper called Beyond Accuracy, Behavioral Testing of NLP Models with Checklist. I definitely recommend reading this. It was a prize winner at an ACL meeting recently. And the idea is that we can kind of write, instead of just reporting the accuracy of NLP models on some benchmarks, we could write tests like in a checklist of tests that tell us about its behavior. And that can be part of understanding, how deployable are they? And also detecting regressions. So for example, this is just one possible test of many. Given a sentence like, I just love the new Honda I bought from Crystal, we could introduce a randomly inserted typo to get this sentence A prime, where now instead of it's IJPST, which is not a legal word in English. So it's still mostly the same, but we've got this typo. And if we have a sentiment classifier, so some model F that takes in sentences and determines, okay, is this positive or negative sentiment? We hope that, most of the time introducing these typos won't really throw off our sentiment detector or classifier. It's not going to give us a totally new answer, right? Like, you still love the Honda. So we want this kind of robustness to typos. And if we're finding a lot of non-robustness to typos, that indicates that maybe the model's pretty fragile and brittle. Maybe it's not really learning the features we want. So this is just one way to go beyond accuracy. So what we did was we created a workflow. So when we switch the model, so here we were doing this with Hugging Face models, the Hugging Face transform models. I can't recommend them highly enough. They're really easy to use. And so we were able to switch from one trained sentiment classifier, Albert, to another trained on which is using the Distilbert model. These are just kind of small models that are meant to, capture the BERT language model, which is really popular and eminent right now. But we're playing with two different ways of having a shrunken version of BERT. And we can run inference on the GitHub Actions, just CPU machines. So, that's how tiny we are. but you could use a GPU, as I've shown you, but this example doesn't. And so what we did was pip install our requirements, we ran the perturbation test, and then we generated this report. So we're using DVC to do some comparisons between how how we performed on this branch versus what's on the main branch. And then we printed out some failure modes. And so what this means is that I can see that my accuracy on the test didn't really go down when I switched the language model. So that's good. We don't really have a regression there. But the failure modes are kind of interesting. I can see that, the first one, from changing from such an inspiring car to such a, I don't even know how to pronounce this word, car, like, yeah, that's pretty reasonable that, the model might be thrown by that and not know if that's a positive or negative sentiment. But then some of them are kind of weird. Like, we have down here, the sales department is about as helpful, knowledgeable, and straightforward as I've ever seen at a car dealership. And the only thing that changed is that instead of spelling about with an A, now it's spelled with the Z. So it's Zbout. And for whatever reason, the model is really, really confident that now this is a negative sentiment. And that is a little bit weird. So that might be something that's worth exploring further. So this is kind of an NLP example, but you might be able to see how, if you were doing image segmentation and you had a couple of classes, perhaps you could, print out some failure modes from those classes, or you could look at a slice of data here. And that's kind of what we're doing. We're starting to look at, where is the model performing kind of funny. And so, okay, so to zoom back out, that was our use case. I'm going to summarize kind of everything I've shown you and how we went about it. So we had this wish list of things that we wanted to make a tool that could do. And so we started working on an open source project, continuous machine learning, to try to meet these goals. So one was we wanted to be able to version data like code. And we actually have that for free because of DVC does that. And to be clear, DVC and CML are not strictly required for one another. You can use them separately, but if you want your data set to trigger, workflows, then DVC is a pretty useful tool for that. We wanted our CI system to be able to allocate cloud resources to train models. And we have now a high level function that lets us do that. So we can use Terraform and, find ways to basically interface from GitHub Actions or GitLab CI with major cloud vendors so that it's pretty trivial to spin up an instance. And we wanted to be able to provide feedback in the form of metric reports. And so we've written these helper functions for writing reports in a pull request. And to be clear, there are lots and lots of solutions out there. So like lots of companies are finding ways to do this, and they're building their own internal custom platforms for managing machine learning experiments, or they kind of have their own conventions where, some of it is manual and maybe some is automated. And so our goal is not to create like a whole new platform that organizations have to adopt in order to get any of these benefits. We're interested in tools that augment existing workflows. So the priority is making data science and DevOps more closely tied to existing CI/CD processes that probably already exist in a lot of organizations. And so that's why we were pretty interested in, not reinventing a CI system. We're going to extend GitHub Actions, GitLab CI. We do have some work on Bitbucket Cloud. We do support CML recently. We recently added for Bitbucket Cloud. And so feel free always in our feature list on the CML repository to always request or vote for a provider that you would like to see supported. So the big picture is, why do we care about CI/CD? And I didn't know about CI/CD, as an academic, and it really impressed me when I joined a startup. It's a way of bringing together your training data, your source code, your modeling experiments all in one place. And this gives everybody on the team access to all versions of the project, including the history and ongoing experiments. And it gives you a standardized format for storing and sharing and even testing, files that are related to your project. So there's a cultural and a technological element here. And I think it really does have a place in full stack machine learning. So thank you for listening. I'm going to take questions now. And please know that we're an open source project. And so we hope that you will join us. Feel free always to open up, a feature request, an issue. Let us know what kind of videos you might like to see. If there's a tutorial or a use case that you're interested in, we have an active, very active Discord support channel. And so then there's a couple places online where you can follow me and our team. And so thanks for giving me the chance to share with everybody today.
Thank you, ELLE. I hope we will have a curious audience. I already see there is some questions for you, so this is nice. I'm also very, very happy that you mentioned this thing that it's important to build on existing tools, that we don't want, companies to reinvent themselves from scratch and just abandon everything. I know this would never work in real life, so I see your point. I would like to start maybe with Natalia questions. She's mentioning, first of all, she's saying you give a great talk. So.
Oh, thank you. Thanks, Natalia.
And then she says that metrics for a model could differ depending from the use case, of course. And how does it work with CML metrics? So do you define the relevant metrics in the beginning to be monitored during the machine learning model lifetime, or can you maybe change them later? How does it work?
Yeah, so there's a few ways to do it. So CML itself is totally agnostic to it doesn't have special types. It just, it's like writing kind of like writing a GitHub README or a GitHub comment. So you can put anything in. So if your metrics will always be written to like a certain file or a set of files, then you would just copy those into the report. And so then it doesn't matter what type they are. But if you use DVC, which, I think has some advantages for if you want to be really rigorous about tracking metrics, then it's like you will declare a metric. And so what you'll do is you'll point to a file, and it will be, usually a JSON or a CSV. Yeah. And then you will have, at every Git commit, you'll have the metrics at that time. And that makes it so that you can do comparisons. And so there, the metric kind of is like a protected, it's a special class. It has something, but also it can be any, it could be any language, any toolkit can make the metrics. But it's just important that you declare it. And then if you were to change the metric or add a new one, then you would do that in DVC. And so that's if you think your metrics are going to change a lot over time, there's some value in using that if you want to be able to roll back the history. If you just want to have whatever comes out of the pipeline, write it into a markdown document and publish it, then you can just do like dump the contents of your metric file into your CML report.
Of course. Okay, then I think Natalie's question was answered, so thank you. Let's move on to Daniel, because Daniel is asking, how does DVC differ from other tools? And he is making the example of Git LFS.
Yeah, okay, great question. So Git LFS definitely has a lot of users, and we have a lot of people who are kind of like Git LFS, like they're tired of it and they end up wanting to use it. And I think that's just because of Git LFS is not trivial, to implement and especially, for a lot of data scientists like myself, like, I think I could learn Git LFS pretty quickly, but it's not necessarily a native toolkit to me. So Git LFS is just fine. There's really no problem with using it. But a lot of people like DVC because you don't have to use an LFS server. You can just use like your S3 bucket or your Google Cloud bucket. You can actually even use Google Drive. So one of the things like at academic, at Michigan,
it's
I'm
good
very
to
much
start.
about this. Yeah, just get the students using their Google Drive in this, and then that's maybe a little bit easier than trying to get people into Git LFS. The other thing is that, other than not having to use an LFS server, DVC has functions like pipelines and then being able to do like track metrics over time. So it has some things built in for experiment management. So you'll get some things out of doing that are specialized for managing the, development stage of a machine learning project that you won't get from just raw Git and Git LFS.
Okay, quite extensive answer. I see your point now. We have instead Balint asking something else. He's asking whether there is a good way to defer two versions of a data set, like you do GitDiff does with the source code, for instance.
Yes. Okay. So this is one place where it's not that easy. And, I think that we'd actually love if you have an idea about this, you should come and share with us. So it's really hard. So a lot of what happens, a lot of the DVC users, like there are some other things that are in, the data versioning space. Like there's lots of other tools here. And one thing that DVC does really well is unstructured data. So if your data is highly structured, like it's always going to be tabular and it changes in very predictable ways, then the DVC way of like every time it changes, we're just making another copy in storage and we're going to hash it. That's not the most efficient if your data changes in very predictable ways. But if your data is unstructured and you can't take advantage of that kind of structure to create a smarter diff, this works pretty well. Because of the types of data that we have and, a lot of our users don't use structured data. We don't have a smart way to do a diff on your data right now. That's just a limitation for sure.
Yeah. So you're not prioritizing structured data. That's the answer.
Definitely not. There are projects out there that are prioritizing it, but we are not that team.
Yeah, I understand. That's a well-explained choice. I also have here David asking something else, and that is, how do you balance the advantages of continuously validation using selected test cases against the prospect of overtraining on those test cases? And
for sure. For sure. It's a really, really good question. And I think this is something that's going to be interesting so kind of as these behavioral tests, I think they'll get more popular. And I think that, that's going to become an issue that I'm kind of curious, will somebody be able to study that? For something like, I'm not even sure, on something like the robustness test that I did, like how in danger are we of overfitting? And I kind of feel like that is something that I'd like to see some empirical study on to know how real that danger is. I think something that would be really cool would be kind of like how there's like code linters that you can kind of take off the shelf. Could we one day have like a big repository full of like, these are a bunch of great tests to run on, NLP tasks, or these are great for image segmentation. And then, you could pull some of them and maybe there'd be different flavors of them. And so it'd kind of be like, there's a library of these tests already written. And then maybe if we have a couple options, you're not as prone to overfitting on just one. But this is a really good question that I think, I'm eager for some empirical research here. Because right now, I just don't know how in danger we are. I don't feel like we're there on data of this size, but I'm not sure.
It's a tummy feeling, but you don't have data. That's the problem.
Right. Yeah.
And also, I forgot to mention that David was also asking whether you can somehow use augmentation to produce new test data. Maybe that's a solution.
Definitely. Absolutely, yes. And Jeremy Jordan does that. He has a library that he's working on, so he's worth following for augmenting your data set for the purpose of running tests. And yes, so follow Jeremy Jordan because this is something that he's working on.
Okay, so now we know somebody else to follow. Let me check if I see some other question for you. Otherwise, maybe I would like to invite you to talk about your YouTube channels and what kind of use cases are there available right now.
Yeah, sure.
I think we ran out of questions. I invite everybody, if you have, we have a couple of minutes more, but in the meantime, I would be happy to hear some example for you, if you don't mind.
Yeah. No, I'd be happy to. Yeah, so we started a YouTube channel just because I feel like continuous integration is one of those things that it can be kind of hard to understand if you're reading it for the first time, but when you see it done, it's like, that's what they mean. You just commit and then this little green check appears, or you might have even seen it many times working on your company's, making a pull request. A lot of teams have it already, and you just, it's like, okay, that's what it is. So I wanted to make videos because I felt like that was going to be much more effective than blogging about this. And so we have some video tutorials that are taking through like a whole CML example. We have a couple with, how to evaluate models that way, and make just a few different image, visualization libraries. I have one that I really like, which is all about doing this in R, because R doesn't get, as much attention sometimes, but R has incredible visualization and table making libraries. And so I wanted to use that just to show, what you can do with that. We have some about how to set up your own on-premise GPU. So maybe you don't want to use a cloud GPU, maybe you have a GPU. So you can set this up, on your own GPU to be the runner. That's a video. I have a video with Jeremy Jordan where we're doing this, doing the NLP use case together and discussing it. So we've got, basically anytime we think of a use case, or somebody, if a question keeps coming up, then we try to make a video about it. So it's a very interactive channel in that I just have a long list of like, every time somebody is like, can you make a video about this? I put it on the list, and like, I think I will over the years get to most of them.
So we should tell the audience they need to ask in a bulk for the same thing, so they will force you to do the next video on a specific topic.
Yes, exactly. Basically, everything in open source is just like, tell us what you want, and if enough people say the same thing, we'll do it.
Of course. Yeah. I really like this approach that you are open to others to help them figure out the technology you're working with. It's
Thanks.
Really moving.
Well, it's very much an experiment. And I mean, I feel like it's kind of an unusual place because a lot of the people that are interested in this are engineers. And then a lot of them are also data scientists who are, kind of learning this for the first time. And so we have like several different levels of expertise in completely different areas here. And so trying to find like, just what is the literacy or the knowledge that's missing to make it so that, they can talk. And it's been really interesting to kind of, be in that space. But I like it a lot. People are really eager to learn, and a lot of people are eager to try, what's something that's going to make the practice a little more rigorous or, automated. I think a lot of people just automation is fun.
Yes, of course. That's why we're here.
Yes.
Okay, and it was very, very nice to hear from you.